All right, hello everyone. Let's go ahead and begin. Just want to real quickly remind you all of what's coming up. We're kind of reaching the end of the semester, so today I'll be introducing the final module, the last bit of new material for this class for the semester. There's no studio this week, obviously, because of Thanksgiving break. You'll do one final studio when you get back from break next week. And then, you have two assignments. So assignment 8, the zombies assignment, is due when you get back from break. And then there's one more assignment after that, which I'm going to give you a little sneak preview of later on today. And then the other thing that you have for this course is exam 3 / the final exam, depending on where you sit, which are also coming up after we get back from break. All this stuff's on the calendar. Just want to make sure you're all aware as we hit the home stretch what there is that's left. I'd also like to remind you again to please take a moment and go through the gradebook. Make sure that everything looks okay. If you see a grade that is blank in the grade book and you feel like you submitted that thing, it is not just going to magically fix itself. You're going to have to ask somebody to fix it for you. So, and that somebody is me. So send me an email, shoot me a message on Piazza if something on Canvas does not look right to you, so that we can get that fixed as soon as possible, preferably before the end of the semester. Does anybody have any questions for me right now about what's coming up in the last couple weeks for this class before we hop into today's stuff? Any questions? Okay. So then I want to start off today with a little note about what we're going to be talking about today. I actually have 3 things that I want to talk to you about today. If you may notice, however, that there was 4 things on the website and in the exercises repository. I've been kind of switching up the way that the end of the class has worked a little bit this semester. Some things have kind of moved around a little bit, shuffled around a little bit. And so recently came to the conclusion that we will not be covering sets this semester. We have covered sets a little bit in the past. There used to be a section on the website for sets in this module. It's gone now. I removed it. There still is a section in the repository for sets. I actually deleted it last class, right before this. You don't have to delete it. You can keep it, of course, if you want to, but that won't be on the exam. Sets will not be on the exam. That's not going to be covered, at least not directly. We are going to talk about them just a tiny bit later on today. But the 3 topics that I want to talk to you about today, and the 3 topics that absolutely will be necessary on the assignments and the exams, are lists, maps, and equality. So those are the 3 things that I have on my agenda for today. We will not be covering sets, so don't worry about that. Don't bother taking up any extra space in your brain for sets. You may need them later, but you don't need them for this class. So in regards to the material that we are going to be talking about, the name of the module is Abstract Data Types. And so the idea for today is to hopefully get you all to recognize that, well, for starters, you're all programmers now, right? You've made it through almost an entire semester of computer science. That means you're all programmers now. And if you choose to go on and take the next course after this one, 247 is usually the next stop for a lot of people. It's called Data Structures, right? And the reason that it's called Data Structures is because after you get your feet wet with programming, you start to realize that what really matters is the way that the data is structured. The containers that we're using to store the data really has a big effect on the code that we write. So today we're kind of trying to get you used to that idea by introducing you to a couple of very commonly used data structures. I'm going to introduce you to lists and maps. These are not the only data structures that exist. In fact, we've already kind of talked about another one, arrays. Arrays qualify as a data structure. We talked about that earlier in the semester. If you take 247, you'll learn about other data structures like trees, like graphs, other sorts of things. Not only that, but in this class today, what I'm going to talk to you about, I'm basically going to show you what a linked list is, show you how to use it a little bit. Same thing with a map. I'm going to show you what a map is, show you how to use it a little bit. In 247, you'll actually look at them in a lot more detail. So not just what is a linked list, but how does it work? When you open up the hood and look underneath, how do all those parts work together? Today, I'm more interested in how do you drive the thing, right? Not really how does the engine work. Let's talk about lists. We're going to start with lists because lists are actually pretty similar to something we've already discussed. Lists and arrays have a lot in common. The biggest differences that we're going to talk about regarding lists and arrays, well, for starters, lists fix one of the things that is usually considered to be a little bit awkward with arrays or not ideal. When I create an array, I say this array has 10 things in it, right? And then that array forever has 10 things in it. It cannot grow, it cannot shrink. If it has 10 things in it, that's its size. The size remains the same. Lists no longer have that restriction. So lists have the ability to grow or shrink depending on however many things they contain. So no longer do we have this fixed size. That's a nice thing. But the other big difference between lists and arrays, perhaps the more important difference, has to do with what we've been talking about the last few weeks. Lists are objects. So linked lists are objects. We're going to be treating them like objects. Arrays are not. Arrays are not objects. We have not treated them like objects. So they are going to feel a bit different. That being said, they do have some similarities. Things in lists are stored much the same as they are in arrays. They are going to have an index. That index is going to start at 0, and it's going to go up 0, 1, 2, 3, 4, all the way until you hit the end of the list, right? So that kind of stuff is going to feel familiar. Let's go ahead and start writing some code and start kind of comparing lists versus arrays a little bit. First thing I'm going to do, I'll say linked list, and with an array, I would have to specify the type of thing that I want in an array, sort of like this, right? Blah, 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 blah. So I say the type of the thing that I want, followed by the square brackets, and the square brackets is what makes that thing an array, as opposed to just one string, right? Okay, we're not dealing with arrays anymore now. We're dealing with lists, linked lists, and so this is what it's going to look like instead. We're going to use not square brackets, but the official name for these is angle brackets. So we're going to put the type of the thing that we want inside of angle brackets. All right. And remember, one of the differences I mentioned between arrays and lists, linked lists, is that linked lists are objects. So what am I doing right here? Calling the constructor. That's right. I'm calling the constructor. I am constructing a new linked list object. This linked list is going to contain strings. That's what's going to be in this linked list object. Now, you can see that Eclipse is a little bit unhappy with me. Eclipse is saying it doesn't know what a linked list is. Well, it does know what a linked list is. Java provides a linked list for us. We just have to import it. So if you click the little import link up here, that should hopefully make Eclipse happy. And again, I want to contrast, the difference between what we do here versus an array. If I create an array, I say string array equals new string 10. And now I have an array that can hold 10 things in it. This constructs a new linked list that can also hold strings, right? But this linked list has 0 things in it. It's empty. There's nothing in this linked list. If I want things to be in this linked list, I have to put them in there. I have to put things into this list. So there already is a little bit of a difference, right? This linked list is going to grow and shrink along with the number of items that it contains. So let's talk about how to do that. I want to get some stuff into this list, right? I want to get some stuff into this linked list. So if I was doing an array, I would say, you know, array at position 0 equals something, right? Well, this is an object. This is an object. So in order to use objects, we're going to call methods on them. What methods do we have available to us? Well, that's what the API is for. So I've linked you to the list API, the linked list API. I also linked you to the array list API, and I will go ahead and go on record as saying that for the purposes of this class, I don't care which one you use. They're both potato for this class. Are they different? Yes, but the differences do not matter for what we're doing here. I'm going to stick with linked lists just to be consistent today. Okay? So if I want to know what things are available to me, what can this list do for me, I'm going to look at the API. And here I see the list of methods. Right up here at the top looks like one that might be useful to me called add. This allows me to add something to the list. So instead of using square brackets, I'll say list dot add, right? Instance name dot method name, and then I have to supply parameters. So just give it a string, and that will go ahead and stick that string into the list. It automatically is going to add it, you can see what the documentation says, to the end of the list. Okay, makes sense to me, right? A little different than how arrays do it. Arrays, I have to say exactly where I want this thing to go. Here it's just automatically going to tack it onto the end, but that's okay. That's convenient. That's convenient for us. You may have noticed that this doesn't say that I'm adding a string. It says that I'm adding something called E. So when they wrote this documentation, they didn't know that I was making a list of strings, right? Or a list of doubles, or a list of, it could actually be a list of anything. It could be a list of students. It could be a list of courses, right? Person objects. It could be a list of anything. But it doesn't know that. So E is just a placeholder. E is just a placeholder. That means that if I am storing strings in this list, then I'm going to add a string here, right? E is whatever the type is that the list contains. So we refer to that as a generic type. E is a generic. It just stands for whatever type it happens to be in the list. And you'll notice that there's lots of other stuff that you can use here as well. I don't know what all of these do. I know what some of them do. I've used some of them. I haven't used all of them. When I'm programming, I open this page and I keep it open for reference so that I can look stuff up. I don't have all this stuff memorized. It's not possible. It's too much stuff. So, yeah. Let me go ahead and add in a few more things to this list. You can kind of see where I'm going with this one. I'm not going to do all 7 days of the week. That's not really necessary. I just want to put some stuff into the list. And then I'm going to try to print it out. And let's see if we can see what the contents are of this list. There we go. Beautiful. We can also verify that it looks like, you know, this add method did exactly what I thought it was going to do. When I added Sunday, it added it onto the end. When I added Monday, it added it onto the end. When I added Tuesday, it added it onto the end. We can see that now, right? You can actually see that's the way that it worked. One thing that we often did with arrays is that we would write a loop and go through and visit each element in an array and do something with it, right? We can do that here. Let's see what that looks like. Remembering that we're not using arrays anymore, we're using objects, we're using linked lists. All right, so for int I equals 0, I is less than, okay, so if I was using an array, I would say list.length here, right? But this is not an array, it's an object. So I have to find the appropriate method to use here instead. So let's go back to the documentation, scroll around until we see something that looks like it might help us out. And I know that there's one down here that will, in fact, do what we're looking for. So it's not called length like it is for an array. It's called size. Mixing those two things up, though, is like one of the most common mistakes that I see after people learn about lists. You'll still try to use length for a while, I bet, until you get used to it. But it's size. It's an object. We're going to use the size method. Okay. If I wanted to just retrieve an item from this list, you know, if it was an array, I'd do it like this, right? With the I in square brackets. It's not an array. So how do I retrieve something from a list? Well, again, we have to look at what's available to us, see what methods look like they might be able to help us out here. And my eye is drawn to this one called get. I plug in an index, and it returns the element at that position. That sounds exactly like what I would like. So instead of using that square bracket notation, I'll say get I instead. If I run this code one more time here, we'll see that it does go through the list one at a time and print out each of those elements one at a time, just as we would expect it to. So there's a lot of overlap here between arrays and lists, right? One of the questions that I get often is, when would you choose one over the other? I think it's a great question. Lists are convenient if I don't know how many things I need. So if I don't know how many things I'm going to need to have in my list/array, lists work better because they allow me to grow or shrink depending on the number of items that I've got. Whereas arrays, they have a fixed size. Once I create an array, that's how big it is forever. So if I know I have exactly this many things that I need to keep track of, an array might be a better choice. Another thing that I haven't talked about with lists, but we very much did talk about with arrays, multi-dimension. So two-dimensional arrays. You can actually do three-dimensional arrays or however many dimensions you want, right? With lists, it's not really a thing. You can kind of do it if you want to, but it's a bit clunkier. So if I'm dealing with something across a two-dimensional space or a three-dimensional space, arrays just work very, very, very well, very naturally with those types of problems. Lists, not so much. They're not really a great fit for that kind of thing. So that can kind of help you choose. There might be other situations in which you're not really sure. You think about it and you're still not sure. Okay, whichever one you want then. They do a lot of the same stuff. There are going to be situations in which both tools will be able to get you to the same place. That is, in fact, the case. Yes, question?
I'm just curious, what is a 3D array?
I'm sorry?
What is
A
a 3D array?
3D array? Well, yeah, so I mean, if I have a 1D array, 2D array, 3D array, so a 2D array would have a row and a column. Well, a 3D array is going to have a row and a column, and I guess it would be like a height or some other kind of X, Y, and a Z, just like I'd have in three-dimensional space. But computers are also not limited to 3 dimensions like us, humans are. So if I want to make, 4-dimensional array, 5-dimensional array, 6-dimensional array, computer don't care. That kind of hurts my brain as a person to think about, but the computer does not care. So yeah, we don't go above 2 in this class, and most applications probably won't go above 3, but it is possible. Great question. Yeah. Great question. I was waiting for somebody to ask me about that. Yeah, so linked lists can store whatever we want them to store, but if we want to store integers and we go and we try to put int here, it doesn't like that. It doesn't like that. If we want to store integers in a linked list, we actually have to say it a little bit differently. We have to say integer with a capital I. The reason is, I would argue, not very important. It's one of the least important things for you to care about. But to explain it, we're dealing with objects now. Everything is objects all day long. So the linked list wants to store objects. And ints are not objects. So what Java has done, Java has provided this integer class, which does everything that lowercase int does, right? It's just in an object now, basically. And that way we can use it with linked lists and other types of data structures. Yeah, good question. Same thing is true for double. You have to capitalize it, right? To use the object type, whereas if you use double with the lowercase d, that's not an object, so it's not going to like it. Yeah, it is a confusing little point, for sure. Have to use an object type here. Great questions. Any other questions about lists? So I start with lists because obviously there's a lot of parallels between arrays. Lists have an order, right? They always start at 0 and they move up in order. The order does not change unless I change it by moving things around, right? So the list will remember the order that things get stored in. That turns out to be important because we're going to take a look at another structure that is very different from lists and very, very different from arrays. The structure we're going to take a look at next is called a map. So both arrays and lists use kind of the same sort of technique for structuring our data using an index, starting at 0 as our first index and just counting upwards. What a map tries to do is it doesn't use an index. Instead, we're going to be making associations between keys and values. So I get to specify so every entry in a map is going to come in the form of a key-value pair. So instead of going 0, 1, 2, 3, 4 in a map, I have to look things up not by an index, but by a key that they're associated with. And the nice thing about doing it that way is that a key can be anything. So my key is probably... my key, if I really wanted to, could be 0, 1, 2, 3, 4, 5, 6, just like a list is. But more often than not, it's going to be something totally different. So I'm going to associate keys with, some other type of object based on whatever problem it is that I'm trying to solve. So let's take a look at an example, starting with, I'm going to switch to this phone book example in the maps section. Here's how we create a new map. Notice that inside of the angle brackets, we've got two types. So with a list, I just said, I'm going to make a list of strings. I'm going to make a list of students. I'm going to make a list of courses, whatever the case may be. With a map, I have to provide two types, a type for the key and a type for the value. So the first type that's given here, the string, that's the type of the key. And the second type that's given here, integer, that's the type of the value. So what I'm trying to do here is I'm trying to use a map to act as a little phone book. So the keys, the strings are going to be names, people's names, and the values, the integers, will be the phone numbers. So I'm making associations, right? This person's name is associated with this phone number. This person's name is associated with this phone number. This person's name is associated with this phone number. Key value pairs. Key value pairs. Okay? Let's go ahead and take a look at the code and just kind of walk through it line by line here, see if we can understand some of the basics of what maps are. And you also probably, I know I would like to pull up the map documentation. I think that would be a good idea for you to do as well. If you, I think I linked it to you right here. Okay. So first things first, we're going to create a brand new map. And the first thing we try to do is we try to print out our brand new map. And we can see it's empty. there's nothing in it. Anytime you see curly braces like that, that's an indication that we're working with a map, usually. Just like square brackets are usually an indication that we're working with a list or an array. Curly brackets usually, but not always, indicate that we're working with a map. So this is what our empty map looks like. There's nothing in it. You can see that if I print out the size, it tells me that the size is 0. This next line here, line 14, I'm trying to look something up. So I'm going to this phone book and I'm saying, hey, do you have the phone number for Ghostbusters? Or tell me what you think the phone number for Ghostbusters is. So pay attention to how we're doing that. I'm saying get whatever value is associated with the key of Ghostbusters. So I plug in the key, the map tells me what the value is. Remember though that we haven't put there's nothing in this map yet. The map is empty. There is no phone number for Ghostbusters. It's not in there. Nothing's in there. So the map's going to try to look up the phone number for Ghostbusters. It's going to fail. And so you can see the value that we get back is not a phone number, but null. So let's fix that. Let's put some stuff into this map and see how that changes things for us. The next entry here shows us how we can actually start to put some content into our map. Remember, I'm making associations. So anytime I put something into a map, I have to give you a key value pair. I have to say, here's the key and here's the value that I want to be associated with the key. So we're using the put method. This is the key and this is the value. Notice that the types match the given key and value types that I've given. I'm saying add an entry to the phone book that says the Ghostbusters phone number is all 5s. So let's look at what our map is going to look like after we add that phone number in, after we add that key value pair. If I print out the map now, you can see, okay, there's the key value pair. There's the association. Ghostbusters has a value of 555 associated with it. The size is 1. And now, when I say phonebook.get and plug in the key of Ghostbusters, it actually gives me back the phone number. It gives me back all 5s. We can see that. Here. So think about what that means. If I go to a map, I say, give me a value for this key. One of two things is going to happen. If that key exists, it's in the map, then it's going to find that value and give it back to me. If that key is not in the map doesn't know what that key is, hasn't seen it before, it's going to give me back null. That's an important little piece of information. If I look up a key from a map and it's not there, I get back null. Otherwise, it'll give me whatever value is associated with that key. All right, let's extend this out. We're going to add some more stuff. We're going to add some more stuff to the map. Here I put in a number for Jenny, and then here I put in a number for Saul Goodman. And notice that Saul Goodman happens to have the exact same phone number as Ghostbusters. Is Saul Goodman Ghostbusters? I don't know, but they have the same phone number at least. Is that okay? What's our map going to do? Can it handle that situation? What's going to happen? Well, let's take a look and see. After I add those entries, we can print out our map again and take a look and see that, okay, it actually has no problems with that. I see here's my entry for Saul Goodman, here's my entry for Ghostbusters, and they both have the same value. I can have the same value appear in the map more than once. That is okay. That is possible. That is fine. That's not a problem. But let's think about the keys for a second. Can I have the same key in the map more than once? Think about what that would mean. That would mean that if I plugged in Ghostbusters, I would see, or if I looked up Ghostbusters, I'd have 2 entries, right? Ghostbusters could have 2 phone numbers in the map. How's the map going to handle that? What's the map going to do? Well, let's take a look and see. Here, I'm saying to put in this number for Ghostbusters. So we already had all 5s in there for Ghostbusters. I'm now saying, all right, put in this number for Ghostbusters. In order to find out what happens, we actually have to come down here and add a little line of code to print out our map one more time. So let me do that real quick. Oops, it's called phone book. And if we examine the results now, we can see that, okay, Ghostbusters still just appears one time, and the old number that used to be in there is gone. It has been replaced with the new number that we gave it. So values can appear more than once. Keys cannot. Each key is unique. Each key in a map can only appear one time. If I try to put in a second value for the same key, it's just going to erase the original value. It's just going to replace it. Keys are unique. Cannot have duplicate keys. So the two main operations really to pay attention to for maps are put and get. Put is how we put information into a map, and get is how we get information out of a map. But again, remember that we're not dealing with indexes anymore. We're dealing with keys and values. There's lots of other stuff that maps can do. For that, I'll refer you to the documentation, right? You can review this yourself. But one thing that I think, again, that's important to understand and realize as programmers is that when we're starting to write a program, it is up to us to decide the best data structure to use to solve that problem. So in some situations, a list is going to be the right data structure to use. And in some situations, a map is going to be the right one to use. And in other situations, it might be some other data structure that you haven't learned about yet. But how do you make that decision? What information can you use to make that decision? Well, let's talk about how maps and lists are not the same, right? We've already kind of touched upon that a little bit. I tried to illustrate that with the duplicates, right? Lists can contain duplicates, right? Very much so. Maps can have duplicate values but not duplicate keys. Another important distinction between maps and lists very much care about order and retain the order of the items. Maps do not. There is no concept of order here. The order of the items that are in a map is completely arbitrary. The computer does not track the order of items in a map. It kind of makes sense, right? I don't have an index anymore, I just have keys. And those keys aren't really going to be in any kind of particular order necessarily. Might lead you to another question, though. If there's no order, if there's no index, how can I use a loop to go through a map and print out all the stuff? Right? You can't just write a loop that says for I equals 0, I less than the size of the map, I plus plus, because even if I had that value, there's no index, right? There's no way for me to plug that into the map. There's no way for me to plug 0 into the map and get something back. That's just not how maps work. I need keys, not indexes. I need keys. I need a way to iterate through all of the keys of a map so that I can use those keys to retrieve the values of the map. And that is, in fact, the way to do it. In this second file here called keys, I provided you, so this is the same sort of phone book setup from the previous example. Down here, I provided you two different ways of using a loop to iterate through a map. These two loops do the same thing. It's just two different ways of doing the same thing. In both cases, however, we're iterating through the keys, and I mentioned that we would talk about sets just a little bit today. Here it is. The keys of a map are a set, and that's really all I really care about in regards to sets. I'm not going to talk about sets in detail, the properties of a set or anything like that. But what you will notice is that I'm not using an index here, right? I'm using a for each loop There is no order. I could not say for int I equals 0, I plus plus here. If I wanted to, there's no order. There's no index. I have to use a for each loop. I have to loop through each element from the key set directly and then plug that into the map to get the values out. That is the proper way to iterate through a map. For your purposes though, right? If you have a map, you want to iterate through it, here's 2 different ways you can do it. That's really the main thing that I wanted to show you with this example. Here's a couple ways you can use to iterate through a map. The bigger picture thing, if I have stuff where order matters, use a list. Lists keep track of order. If order does not matter, or it's more important for me to make key value associations, then maps are the better structure. Both are very, 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 very common data structures that you're going to see all over the place. Yeah, I have one more topic to talk to you about that's a little bit different than these two. So before I do that, does anybody have questions about lists or maps before we head on over to the final topic of the day? Yeah, in the back. Yeah. Can lists have different data? So I mean, I'm not sure I can switch this with any type that I want, right? So the stuff inside of angle brackets I can do, this can be a student, right? This could be a person. I'm not sure if that's what you meant.
No, I just wanted to know a restriction of arrays that parallel arrays.
Same restrictions here. Yeah, actually using parallel lists is still a thing, just like you would use parallel arrays. Yep. Actually, the one tool that we've seen recently that kind of helps us move away from parallel arrays is not linked lists, but inheritance. Inheritance lets us group things together by their base class, so that can kind of help us out with that problem. But using parallel linked lists is still an effective technique, just like using parallel arrays is. Good question. Yeah. Any other question about maps or lists before we head on to our third and final topic for the day? All right, our last topic does not have to do with the data structure, but still has very much to do with objects. Really, I want to talk to you about equality. You might be wondering, why do we need to talk about equality? We already know double equals, right? And that's true, we do know double equals. But now that we have objects in play, double equals is actually not quite good enough for all the situations that we find ourselves in. I would like for you to consider that there's actually more than one way of defining equality, which might seem like a weird thing to say. But consider that there's equality in the sense that I'm talking about the exact same thing, right? So I can have, or another way of thinking about it is, I can have 2 different names for the same exact object, right? A lot of you call me Professor Shook, but when I go home, my 5-year-old daughter does not call me Professor Shook. That would be kind of weird. She calls me Dad, right? Both names refer to me, the person. And so one definition of equality is this idea of, does Professor Shook and Dad refer to the same object? Are they equal? Are they talking about the same thing? That's one definition of equality. Another definition of equality might look like, okay, are they equal in the sense that I don't care if they're actually the same physical thing, but do they look the same, have the same properties, act the same, are they functionally equivalent? So that's if I extend that out, that would be like if there was a clone of myself walking around, right? If I had an identical twin that was exactly like me in all ways. So we would be equal in the sense that we look the same, we act the same, but we would not be equal in the sense that we are 2 separate entities, right? We are 2 distinctly separate human beings. The same concept exists in our code. And in order to understand the differences between those types of equalities, it's important to understand the concept of a reference, what a reference means. So let's take a look at an example. I want to walk you through this example, and I'm going to draw actually a diagram as we go through this example using my wonderful MS Paint skills to illustrate exactly what this code is doing. So first, this is the very, very, very simple class that we're using. It's a person class with two instance variables, one for the name and one for the ID. Okay? We have double equals available to us, but we also have this method that is called equals, right? So what I'm hoping to show you is the difference between using double equals to perform a comparison and using this equals method to perform a comparison, because they're both useful for different purposes. So let's scroll down here and start to sketch our diagram. The very first line that I have down here, I am creating a person. I'm calling the person constructor. Right? I'm creating a new instance of the person class. I know that because I see this word right here, new. That new keyword is a big clue that I'm calling a constructor. I'm creating a new instance. So if I was to draw a diagram to keep track of the instances that I have over the course of this program, when I come across something that says new person, blah, 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 I would represent that on my diagram by drawing a circle or some other shape. It doesn't really matter. And then inside of that diagram, that would be where my instance variables would go. So I would say name is John Smith and ID is 1, right? So when I say new person, when I say this, right? When I say this, that has the effect of creating this instance. This is my instance. When I see something that looks like this, when I'm creating a variable and setting it equal, what I'm actually doing is creating a reference. So a reference is a label, a name that is pointing at an instance of an object. So the way I would represent that in the diagram is to type the name of the variable that I'm creating and then have an arrow pointing at whatever instance that variable is associated with. Everybody with me so far? So when I call the constructor, when I say new whatever, I'm actually creating a new instance. I'm bringing an object into the world that did not previously exist, right? I had nothing, now I have something. When I create a variable, I'm actually creating a reference that is pointing at that object. It might seem like I'm splitting hairs here, but the difference is important. So then on this second line, it's going to do the same thing, but with a second instance, right? So I'm going to make another circle to represent this second instance. And inside of this circle, the name will still be John Smith, but the ID this time is going to be 2, right? And the reference that is created, that is pointing to this one, whoops, will be called P2. Oh my gosh, I can't do paint very well today. There we go. So we haven't done anything too terribly complicated yet. I've created 2 instances. I've got 2 references pointing to them. And now here, I'm using the equals method. I'm using the equals method. So when you use the equals method says, follow the reference and compare the values of the instance variables. So if I'm asking if P1 dot equals to P2, I'm saying follow the arrows, look at the instance variables. Do those values match? Do those values match? And we'll see that the ID numbers do not match, right? So dot equals, P1 dot equals P2 is false. It's going to look at the values of the instance variables, determine they're not the same, so these are not equal. These are not equivalent instances. That's what dot equals does. It examines the values of the instance variables. Okay, let's keep going and examine this line. This line looks very simple, but it actually trips up so many people. Notice that I'm not using the word new here. I am not creating a new object. I'm not creating a new instance. I will not be adding another circle to my diagram, right? I am, however, creating a new variable. I am creating a new reference. So I will be adding a new arrow to my diagram. I am saying that the reference for P3 should point at the exact same object that P2 is pointing at. So if I go back to my diagram here, that means that I'm creating a new variable called P3, and that is pointing at the exact same instance that P2 is pointing at. After this line of code executes, I will only have 2 instances, but I will have 3 references, because 2 of those references will be pointing at the same instance. Does that make sense? I hope. Yes. Sure, yeah, always. Yep. Always do variable assignments from right to left. Yeah, that has not changed. Yep. If this is confusing to you, again, consider the fact that really all I'm saying in this line of code, right? Think of these as names instead for an actual person. I'm creating, this is Professor Shook, right? And this is Dad. I'm saying Dad is Professor Shook. If you are my 5-year-old daughter, that is a true statement, right? That is a true statement. Yes?
If you were to change the value of P2, how would that work with the point of arrows?
Change the value of P2? Can you be more specific?
Like, if for some reason P2 changed to name.
Yeah, great question. Yep. This is why knowing your references matters. So let's say I did call, P2.setName, right? Because P3 is pointing at the same instance, P3 would also see the changes. Or think about it this way. Professor Shook, Dad, both pointing at the same instance, right? I am Professor Shook, I am also Dad. If I have a birthday, does Professor Shook's age go up? Yeah. We celebrate birthday at home, me and my kids. Dad's age goes up by 1. So does Professor Shook's, right? They are pointing at the same instance. They are the same person. They are the same thing. Right? It's confusing. It's abstract, I know. That's why we're going through this example, to hopefully try and help clarify. Let's return to this question of equality. So again, when we say dot equals, I'm saying follow the arrows and examine the values of the instance variables. So here, if I follow P2 and I follow P3, I'm looking at the same instance variables. So dot equals is going to be true, right? But let's talk about double equals. Double equals is a little bit different. Double equals says, follow the arrows. Are they pointing at the same instance? Are they pointing at the same instance? So right here, if I look at this line, P2 double equals P3, I'm quite literally looking to see if these arrows point at the same circle. P2 double equals P3 is true because P2 is pointing at the same circle as P3. The values of the instance variables have nothing to do with it. It has everything to do with the fact that they're both pointing at the same instance variable. So, when you're thinking about dot equals versus double equals, it really boils down to what kind of equality you're looking for. Dot equals is looking for, it's looking at the instance variables. You could be dealing with 2 separate objects, right? That just happen to have the same values. Dot equals is happy with that. Double equals, however, is asking the question, are these references pointing at the same thing? Are they pointing at the same thing? Or another way of thinking about it, if P2 double equals P3 is true, if this is true, then P2 and P3 are the same thing. There's only one object here, and P2 and P3 are both pointing at it. Right? If this is false, that means they're separate. So if I have a doppelganger, an identical twin, exactly the same as me, double equals is false. Even though we look the same, act the same, have all the same properties, we are not the same person. Double equals would be false. But dot equals would still be true. We look the same, we act the same, dot equals would be true. That is the difference between those two. Again, when do you use which? It depends on what you're trying to do, right? You as the programmer now that you are learning the difference between double equals and dot equals, it's up to you to think about, okay, this is what I'm trying to do. That means that dot equals is the right tool, or double equals is the right tool, depending on the objective that you're after. So if we continue this out a little bit, right? Still a little bit more to talk about with this example. Person 4. So here I am calling the constructor. This would make a new circle for my diagram. Notice that the instance variables for this happen to be the same as this instance, right? I'm making a doppelganger, making a clone. So in this situation, P4 dot equals P3 would be true. The instance variables look the same. P4 double equals P3 would be false. The instance variables look the same. They may look exactly the same, could be identical, but they are not the same instance. They are two distinctly separate instances. That's what double equals is looking for. Any questions about that? All right, I'm going to add one more little wrinkle to this then. Double equals works the same for all objects. We don't get to choose that. Double equals just does what it does. Dot equals, however, we get to decide how that works. And the way that we decide how that works is by deciding which instance variables we care about. So for this example, you may have noticed that I use the name John Smith for all of these, right? But actually, the name doesn't matter when determining equality. If you look at the code, or even if you just think about it, you don't even need to look at the code, right? Two people can have the same name and still be different. That happens all the time. There are plenty of people in the world that have the same name. That happens all the time. It's the ID number that makes them different, right? So two people I would not expect to have the same social security number or student ID number or whatever the case may be, even though they could have the same name. So actually the name does not factor into the equality at all, would be my argument. I don't need to look at the name to determine if two people are equal. I just need to look at the ID number. Because whether or not you have the same name does not really tell me whether or not you're in a quote-unquote equivalent person. The ID number is what helps me make that distinction, right? So the equals method only includes the ID. It does not include the other instance variable. All equals methods follow a similar format. They're all going to include something that looks very similar to this junk up at the top, and then they're going to compare some instance variables down at the bottom. This pattern is, so prevalent that programmers rarely write equals methods themselves. I have been programming for a very long time now, and I could not even tell you the last time that I sat down and typed this code out for an equals method. It doesn't happen. I don't do it, and I don't really think that you should either. Instead, I would encourage you to use Eclipse to help you out. The decision that we have to make when determining equality is which instance variables matter. That's it. That's all we really need to care about. The rest is just the code that's necessary to make the comparisons across those instance variables. So here we have a very simple point class, and let's assume that this point class has two instance variables, x and y. And now I want to make a simple equals method. Well, I could try to start typing out an equals method, but I would much rather let Eclipse do it for me by going here to source. And oh yeah, we saw how to do getters and setters. I showed you that a little bit ago. Right nearby, you'll see hash code and equals. They always come as a pair. I know I'm not talking a whole lot about hash code in this class, and I'm not going to. They are related to each other. If you take 247, they'll go into that in a lot more detail. I'm mostly just concerned with equals for today. If I click this little window pops up. It's asking me to select which instance variables I wish to use to determine equality. So for a point, I would argue that I need both of these, right? 2 points aren't equal unless both the x coordinates and the y coordinates are equal. But if I was talking about the person class, right, and it said name and ID here, I would uncheck name, right? The name of a person does not affect the equality. It's really just the ID that affects the equality. That's your decision, though. As a programmer, you have to think, all right, what makes two of these things equal? Which of the instance variables that are available to me can be used to determine the equality of these objects? So check the ones that are relevant, uncheck the ones that aren't. Click the generate button, and then poof, Eclipse will happily spit out the equals method, and you'll see that it includes all this weird stuff up at the top. And then down here is where it actually checks the fields, right? Do you need to go through this and understand how each line of this code works? No, definitely not. I don't. Do you need to understand that equality is determined by comparing instance variables of a class? Yes, absolutely. That's what I care about. Very much so. Should you know that you can use Eclipse to generate these for you by choosing which instance variables you want? Yes, absolutely. I would like for you to know how to do that. That's a good thing to know how to do. But this is very important. Determining the equality is very, very, very important thing to know how to do as well. Any questions about that? Yes. Happy to, yeah. So this hash code thing, again, that's another method that I've never written myself. It's almost always going to be automatically generated. I just don't, it's not a topic I'm going to go into today. Just tagging along for the ride. I wanted to leave you today with a little sneak preview of the final homework assignment. So the final homework assignment, after you complete the zombies assignment, we've got one more after that. We're going to be asking you to create a little snake game. I feel like most of you have probably seen and or played snake game before. So just wanted to leave you today with a little sneak preview of what that might look like. I coded this up this morning. So the blue dot in the middle is the snake, and the red dot is the food, and I can use the arrow keys to kind of move around the screen, right? And then when I pick up the food, my snake starts to grow. Oh shoot, I missed. There we go. And every time I eat the food, it just makes a new, oh my gosh, that's not a good spot. Is that gonna get it? Oh, okay, yeah. So every time I eat the food, my snake grows by one more segment. You can see it's drawing the snake as it gets longer and longer. That's a linked list, right? It's a great use for a linked list because my snake's going to keep growing and growing and growing. I'm going to keep adding new and new segments onto it as soon as every time it eats the food. And then eventually, I will crash into the wall, and that's going to end the game. Yeah. So that's going to be your task for assignment 9. In fact, I am almost ready to get this posted. I just have to put some finishing touches on the instructions, and then I think they'll be up maybe even as soon as tomorrow. So if you want to get a jump start this assignment over break. Keep an eye on the website. Those instructions will hopefully be up soon. Otherwise, that's it. We've covered everything that I'm going to be covering in this class for this semester. So all you got to do is wrap up the last couple of assignments and get ready for the exam. And let me know what I can do to help you out with that, okay? Have a good break, everybody. I'll stick around in case anybody has any questions. Otherwise, I'll see you after Thanksgiving.